Hello, welcome back to my channel. So in this lesson we will look at inequalities, definition of inequalities, or inequality signs and symbols, and solving linear equalities and compound uh, inequalities. And we are going to look at the rules of inequalities. If you are new to this channel, please remember to click the subscription button below. So let us continue with the lesson. By definition, an inequality is a statement that says one expression is an inequality is a statement, okay, that says one expression is greater than or less than, greater than or equal to, or less than or equal to or another one, okay. That is just an inequality. Alright, okay, where this symbol is called less than, and this one is called greater than, okay, or strictly greater than. This is strictly less than, and this is less than or equal to, okay, and this symbol is known as greater than or equal to. So these are the basic inequality symbols, and our inequality statement says one expression is greater than, less than, greater than or equal to, less than or equal to another. For example, we can write 3 is less than 5, which is true. We can also say 3 plus 2 is less than 5 plus 2, okay, and we can also say 10 minus 1 is greater than or equal to 8 plus 1, okay. So these are called numerical inequalities, okay. These are numerical inequalities, and they are true, and they also represent inequality. We can also have algebraic inequalities, but before we look at inequalities further, let us consider the rules of inequality. We call this the rules of inequalities. Rules of inequalities, okay. So rules are laws that guide the operation of something, okay. So with this rule, if you obey this rule, you'll be able to work with inequalities without any problem. So the first one is called non-negative property. That is, for any real number a squared is greater than or equal to 0. This is what it means in word. The square of a real number is negative. The square of a real number is negative. For instance, if a equals to 2, the square of a real number is never negative. Never, sorry. Remember the word never, that is, cannot be negative. For example, 2 squared equals to 4, and 4 is greater than 0, okay. Minus 2 squared equals to 4, which is greater than 0. Minus 5 squared equals to 25, which is greater than 0. So the square of a real number, whether positive or negative, cannot and can never be negative. That is rule number 1. Take note. So in general, if we have minus x squared equals to x squared, and x squared is greater than or equal to 0. Rule number 2 is called the addition properties of inequalities. Okay, so it says for real numbers a, b, and c, if a is less than b and then a plus c is less than b plus c. Okay, and if a is greater than b, then a plus c is greater than b plus c. In words, it means the addition property states that the sense or direction of an inequality remains unchanged if the same number is added to each side. For instance, let a equals to 5, okay, and b equals to 12c, and c equals to, let's say, 2, then of course 5 is less than 12, right? Then 5 plus 2 would definitely be less than 12 plus 2, and of course 7 is less than 14. So it's true. Now let's a equal to 12 interchange, b equals to 5, and c equals to 2 as well. Then 12 is greater than 5. So it then implies that 12 plus 2 will be greater than 5 plus 2. And of course, 14 is greater than 7. So you can see that it works. So when you add a constant number to both sides of an inequality, it does not change the sense or the direction or the sign of the inequality. Rule 3 is called the multiplication properties for inequalities. For real number a, b, and c, if a is less than b and if c is greater than 0, then ac is less than bc. Okay, so take note of this. For example, let a equals to 5 as well, let b equals to 12, and c equals to 2, which is greater than 0. Then of course 5 is less than 12, and 5 times 2 is less than 12 times 2, which is 10 less than 24. So it's 2. True. Now the second part is if a is less than b and c is less than 0, then ac is less than bc. Okay, take note of this. If a is greater than b and c is greater than 0, then ac is greater than bc. Okay, and if a is greater than b and c is less than 0, then ac is less than bc. Okay, so this one and this one, they are telling us that whenever you multiply an inequality with a negative number, the sense of the inequality changes. Okay, so whenever you multiply an inequality with a negative number, when you divide or multiply an inequality with a negative number, the sense of the inequality changes. For instance, let a equals to 5 and b equals to 12, and let c equals to -2, and of course 5 is less than 12, then 5 times -2 will be greater than 12 times -2, okay, which is -10 greater than -24. And of course it's true. If you draw a number line to represent this statement here, say you draw a number line to represent this statement using a number line. So if you use a number line, what we are going to have is something like this. So -10 is somewhere here, -24 is somewhere here. So and if you are moving this way, you move because this is greater and this is less. So it then implies that -24 is less than -10 on the number line. This is to the right and this is to the left. Okay, so that is a simple illustration of what we have explained over there. Now the reciprocal property states that if a is greater than 0, then 1 over a is greater than 0. Okay, if 1 over a is greater than 0, vice versa, then a is greater than 0. And if a is less than 0, then 1 over a is less than 0. For instance, e.g., let's say let a equals to 5, which is greater than 0, then 1 over 5 is greater than 0. So let's say let a equals to or minus 2, which is less than 0, then 1 over minus 2, which is minus 1 over 2, is also less than 0. So that is how this one works. Okay, now we have the interval notation for inequalities. An alternative to using inequality signs is to represent the inequality using a number line. Okay, these are called number line. So in the first example, we have the interval of the inequality is closed. Okay, a is less than or equal to b less than or equal to a is less than or equal to x less than or equal to b. So the circle on a and b will be shaded and we join the line together. Okay, this is a closed interval. Okay, the second one is half closed and half open. It is close to the end of a and opened to the right of b. Okay, the second one is also half open and half closed. It is closed on a and it is open on a and closed on b. And the last one is called an open interval, completely open to the right and to the left. So when an inequality is open, you do not shade the circle on the number, but when it is closed, you shade the circle. And these are examples of compound representation of inequalities. Now we want to look at solutions of linear inequality in one variable. So these are inequalities that can be written in the form ax plus b. This is the format of writing them: ax plus b greater than or equal to 0, where a and b are real numbers and a is not equal to 0, because when a equals to 0, the inequality becomes a constant or a numerical inequality. So the symbol greater than can be replaced with any of the inequality signs as written. So if we are solving linear inequality in one variable, we solve it the way we solve equation, taking into consideration the signs of the inequality. And remember that adding a constant to both sides, or adding or subtracting a constant from up to both sides does not change the sense of the inequality, but when you divide or multiply both sides of the inequality by a negative number, the sense of the inequality automatically changes. Now let us look at examples. Example 1, solve for x and graph the solution. Solve for x and graph the solution. We have a, so 3x plus 2 greater than 0. So here what we do is to subtract 2 from both sides. If we subtract 2 from both sides, we have 3x is greater than minus 2, and then we divide both sides by 3. So we have x is greater than minus 2 over 3. And on a number line, this is greater than, let's say minus 2 over 3 is somewhere here. The circle will be open because the inequality is straight, and the arrow will point to the right because it is greater than. For b, we have 5x minus 7 is greater than 2. Okay, so first of all, we add 7 to both sides, plus 7, and then this gives us 5x greater than 2 plus 7, which is 9. Okay, and then we divide both sides by 5. Divide by 5, so that will give us x is greater than 9 over 5, which is the same thing as x is greater than 4 over 5, which is the same thing as x is greater than 1.8. okay, and on a number line, this can be represented as 1.8. It is greater than and it is straight, so the arrow points to the right and the circle is unshaded. This is x-axis. Yeah, so taking let us take D, let us take C instead of that. Let us take C. 2 minus 3x is greater than 1. So for C we have 2 minus 3x is greater than or equal to 1. So first we are going to add subtract 2 from both sides, okay, and that will give us minus 3x greater than or equal to minus 1, okay, and then we divide both sides by minus 3 by minus 3. Now the inequality sign will change, so what we have there is x is less than or equal to 1 over 3, okay, and on a number line we have 1 over 3 which is positive, we have 0 somewhere around here, and because it is less than or equal to, we are going to shade the circle and the arrow will point to the left, and this is the representation, okay. So what you are going to do now is to pause the video and you try this one as an exercise. Example number 2. Solve for x and grab the solution. Solve for x and grab the solution. A. 7 is greater than 2x minus 1. Okay. Now we add 1 to both sides. Okay. Do away with the constant. So this will be 8. 8 greater than or equal to 2x. Okay, and this can be rewritten as 2x is less than or equal to 8. So if we divide both sides by 2, 2 goes into here, 2 here, 2 here is 4. So we have x is less than or equal to 4, and the graph of the solution will look like this: 4. Okay, the inequality is less than or equal to, so we shade the circle and the arrow point to the left because it is less than, and this is the x-axis, and let's say 0 is somewhere here. 1, 2, 3. So the B part, minus 13 is less than 3x plus 2. Okay, so taking this, we subtract 2 from both sides, and that will give us minus 15 less than 3x. And then if we divide both sides by 3, we have 3 here is minus 5. 3 goes in 3, give us that. So this is minus 5 less than x, which can be written as x is greater than minus 5. So the number line is given this way. Minus 5 can be around this place, and the inequality is straight, so we don't shade it. The greater than, so the arrow points to the right, and that is the solution, guys. So let's take C, and then you do the remaining one as an exercise. So we are taking C, which says C says 20 is greater than minus 5x. Okay, so we have 20 is greater than minus 5x. Yeah. So what we need to do is to divide both sides by minus 5, and remember that when you are dividing both sides by a negative symbol, the sign will change. So this is minus 5x over minus 5. So the sign changes. This is 4. Minus goes in minus. 5 and 5 we have 1. So this is minus 4 less than x, and which is the same thing as x greater than minus 4. And on the number line, this is going to look like something of this nature, unshaded, and the arrow points to the right, and this is the x-axis. So you are going to pause the video now. You take this one as exercises. Okay, take this as exercise. Further example, solve for x and graph the solution. So we have a here. 3x plus 1 is greater than x minus 2. Okay, now first of all, let us subtract 2 from both sides. So that will give us 3x is greater than x minus 4. And then we subtract x from both sides now. So that will give us 2x is greater than minus 4. And then if we divide both sides by 2, 2 goes into, we have 1, 2 goes in minus 4, we have 2. So the answer is s is greater than minus 2, and the number line can be represented this way. X is greater than minus 2, so the arrow points to the right because the inequality is greater than, and that is what we have there. This is x. So for B, we have 2x minus 3 less than 5x minus 7. Then we collect the like terms, additive inverses. Let's add 3 to both sides. So that will give us 2x is less than 5x or minus 4. And then we can subtract 5x from both sides. Okay, and that will give us 2x minus 5x, we have 3x less than minus 4. Then we can divide both sides by 3 now, by 3. And the final answer is going to be x is less than minus 4 over 3. Okay, and the number line looks like something like this, minus 4 over 3. The arrow will point to the left and the circle is unshaded because it is strictly less than. Okay, so let's take C. It is 5 minus 2x greater than or equal to x plus 4. 5 minus 2x. For C, we have 5 minus 2x greater than or equal to x plus 4. Okay, so this is x plus 4. So we'll follow step by step from the left. Subtract 5 from both sides. Okay, that will give us minus 2x greater than or equal to x minus 1. And then we can subtract x from both sides now. So that will give us minus 3x greater than or equal to minus 1. And then we can divide both sides by minus 3 now. And remember, when you divide by a negative symbol, the sign changes. So we have minus 3x over minus 3 is less than or equal to minus 1 over minus 3. And this cancel this, guys. This is plus 1. Let's cancel this, guys, and this is also plus 1. So x is less than or equal to 1, and the number line will look like this. Okay, x is less than or equal to 1, this is 1, and this region is 0. Circle will be shaded because the inequality is less than, and the arrow will point to the left, and this is the x-axis domain. So this is how to solve linear inequalities, guys. So the remaining one has been left for you as an exercise. So make sure you pause the video, you practice them, and you email me if you have any problem or any question. Now the next lesson is solving combined inequalities. How do you solve combined inequalities? Okay, let us I'll leave this till the next video. Okay, we are going to stop here for this lesson. In the next lesson, we'll continue with solving combined inequalities. See you in the next lesson. Bye.